creating tests in Apex. All right, understanding the testing framework, we're going to talk about executing tests, supplying test data, and then testing bulk operations with multiple users. All right, here's an engineering change request. We took a look at this trigger previously, and what it did was it generated a contact by essentially mapping fields from a candidate over to a contact. This is some code that exists in our, maybe we're working on this in our sandbox org. Because we're working in Apex, we're going to need to create some tests in order to verify the integrity of this logic. So Salesforce, our Apex environment, we provide a testing framework. So it's a native testing engine that exists within our platform. We also provide you with tools in order to execute your tests and then analyze the results of running those tests. We also provide some classes. There is a class specifically for testing called test, and then there are also some methods that exist in the system class, some of them which are used frequently within tests, other ones that are used solely within tests, and so we'll be taking a look at those. So what are our goals of our test? Well, first of all, let's talk about what the definition of a test is. A test is a method that's going to execute some target business logic, and it's going to run that in an automated fashion, not necessarily by an end user, but it's the system that's going to be verifying the integrity of that business logic. So whether it's a trigger or something like a controller or custom web service, whatever the case may be. So what are our goals? When we're creating these automated tests to verify the integrity of our business logic, what are our goals? Well, first of all, that the code runs correctly in key use cases. So we need to make sure that if in the case of our sample there with our trigger that generated a contact from a candidate, are we able to successfully create that contact record? The other thing has to do with multi-tenant, our governors. So we want to make sure that when we create something like a trigger, we want to make sure that if we test it with up to 200 records, that we're not overloading our governors. And so we want to make sure that our code is bulk safe, it's bulk ready. We also want to make sure that when someone is making changes, whether it's new code or whether it's actually something like a workflow rule or a validation rule, because the save process involves so many different pieces doing so many different things, we want to make sure that running or introducing, let's say, a new workflow rule or a new validation rule doesn't break our existing code. Same thing goes for a new, let's say, trigger. Okay? So the logic that we're creating is running within the context of this greater whole, and we need to make sure that it operates successfully as an integrated solution. So that's another goal of our tests. And also sort of the negative path, which is, let's say we have some exception handling logic. When we pass some bad data, do we properly handle that exception? Do we, for instance, display an error message to the end user on something like a Visualforce page properly? So when you do a deployment of your Apex code to a production environment, and we will be talking about deployment in our next module, but when you perform that deployment, one of the things that we do is we have 3 requirements that you need to meet for Apex. The first is 75% of your lines of Apex code for all of your Apex code that exists within your production environment must be executed. So what happens here is we essentially count up all of those lines of business logic, essentially lines that are either if tests or they are lines that end in semicolon. If it's a blank line, or for that matter, actually, if it's a system.debug, we do not count it. But what we do is we count up all of those lines. Let's say that you have 5,362 of those lines. We then will execute your tests. We'll keep track of which lines were executed by those tests, and we'll then do some percentage calculations, the number of lines that were executed by your tests, all of your tests, and then the total number, and that's how we come to the number. And then if it's less than 75, we do not allow you to deploy your code to production. If it's greater, we do. 100% of all of your Apex triggers must be called from your tests. So compared to classes, the trigger requirement is a little bit more stringent. There's not a line requirement, but at least one line in every trigger must be executed by your tests. So whereas we could successfully pass our tests if we had 10 equally sized classes and we had 8 tests for those classes, we would have 80% coverage. That would not work in the case of triggers. And then our tests must execute without throwing any uncaught exceptions. So one of the things that we're going to do is we're going to build our tests so that when we have something like a situation where it was a unpredicted outcome, we actually are going to use assertions to throw an exception, and that's the mechanism by which we are notified that our code did not succeed. 75% test coverage is not the goal, it's the minimum. So here are your goals, all right? Where our goal when we're writing tests is not just to get lines of coverage. So if you wanted to, you could create meaningless tests. I mean, you could create, integer I equals 0, and then on the next line, I++, and create, 1,000 lines of code, and then call that silly method, and now you're able to achieve 75% coverage because you have a bunch of garbage code whose purpose is purely there to achieve the test coverage. But you're defeating one of the key reasons that we have our tests. And that reason is that one of the uses of tests is when Salesforce performs an upgrade, and let's say in our case, our next version is going to be Summer 13, we will execute your test logic. And the purpose is to make sure that our new code base isn't breaking your customizations, okay? So there's a very important purpose to these, and if you go out and you create nonsensical tests, you are possibly flying under the radar if we're releasing, a new feature that alters the behavior, or it possibly, breaks your code, if you will. So we have an internal purpose for doing that. So 75% coverage is not the goal, it is a minimum. We have our testing framework, and we have an execution engine for running your tests. The idea is that you can select specific tests to run, or you can run all of the tests within your organization. What we do is we provide you with details about which tests succeeded and which tests failed. We're going to be marking our unit tests. You'll see that we're going to be using some keywords and some annotations to identify what is test code and what is your business logic. But the testing framework never directly calls your business logic. The testing framework calls your test code. Your test code, in turn, calls your business logic. Okay? All right, so let's talk about that. How do we create and run those tests? The types of tests that we want to run, so positive tests, negative tests, and limits tests. So those are the basic, the 3 goals that we have. A positive test is when I pass good data, do I succeed? The negative test is when I pass bad data, do I gracefully handle it? Or if I don't have any exception handling logic, did I get the expected error that I thought, even if I'm just going to display that exception, to the end user? And then finally, is our code bulk ready? So when we stress test it by inserting something like 200 records, let's make sure that we're not exceeding any of our governors. Okay? All right, so what do tests what do they not do? All right, so unit tests don't commit changes to the database. So when you're running your tests, you run them not only in your sandboxes, but you run them in production. And so one of the things that we want to make sure is that we don't leave, any trace, if possible. It's not necessarily universally true, but we try to not leave a trace that test is run. So what we do, if you remember the 17-step process, and if you remember that step 16 was the commit, when we're running your tests, we're going to go through and execute all of that business logic for saving a record. But at the very end, when we get to step 16 to commit the data to the database, we don't do that. We never do that within the context of executing your tests. We also have the same type of requirement that we apply to external databases. So we also don't want, when running a test, to do a call out to your ERP system and insert a fake account or a fake contact or something like that. We do not perform call outs to external web services, nor do we send emails. If you have logic for sending an email, we don't want to send a bunch of emails to your end users. To create a unit test, so a specific test, and by the way, we're using the terminology unit test. These are not necessarily unit tests. In my opinion, they're really apex tests. You might have apex tests that are specific unit tests where you're calling a discrete piece of logic, or you might be doing something where we are creating a test which is not necessarily testing out a single unit of your code. What it's doing is it's doing something like saving a record, and it's testing the integrated solution of running all your Apex triggers, all of your validation rules, your workflow rules, etc. Okay? So when we're talking about Apex tests, we are not limiting it to just doing a unit test. Okay? But if you're doing test-driven development, you're going to have a ton of test code as a part of that process that would result from creating your tests and then as a part of that process. So you're doing it from the get-go. Okay, so how do we create a single test? Well, each test, there's a one-to-one correlation between a method, a test method, and a single test. So what we could do is we could create a method and mark it with either the test method keyword, or we could mark it with the isTest annotation. Okay? This identifies a single test. Now, the thing here is that, let's say I have two tests, A and B. These are independent of each other. So when test 1 runs, and let's say it creates memory, in other words, it's a separate transaction. At the end of it, at the end of the execution of your test method, the full garbage collection occurs, and we remove all of the, variables and static variables and all that kind of stuff. Okay. So each of these methods is independent of the other. A class can also be marked with the isTest annotation. And what this does is when you create a class that is marked with the isTest annotation, what it does is it can only contain code that is going to be run within the context of our testing framework. The advantage of doing this is that all orgs have a soft limit on the amount of code that you can have within those orgs. And by default, it's 3 megabytes. It's a soft limit, so if you call our support, if you reach that level, you can actually ask them to increase it. That being said, they are going to make sure that you used the isTest annotation on your test code, because applying the isTest annotation to that class will make that code not count against that 3 megabyte limit. All right? That being said, we have very few customers who have over 3 megabytes of code. So it's only a few have actually exceeded that. The other thing I want to mention, this is a forward-looking statement, one of the things that they're going to look at doing in future versions is creating the requirement that all your test code exists within is-test annotated classes. So it's a good habit to get into right now because they are going to be moving to a more stringent requirement that you do that. But technically, as of right now, you can have your test code methods co-located with your business logic. What's the anatomy of a test method? Well, a test method traditionally does 3 things. It initializes and prepares inputs for the test. We're going to be working with mock data, and so our first thing to do is to generate the test data that we're going to be working on. The second thing that a test does is it executes the targeted business logic. So in this case, if I wanted to test a trigger, I would insert or to update some records. If I wanted to test out a controller, one of the things I'd do is I'd instantiate an instance of that custom controller. I would then call getters and setters. We'll talk about that more later on in the class. Or for that matter, I might be calling a custom web service and passing a SOAP message to that in the form of an XML document. And then finally, our third step is to verify the results. So we're going to verify the results of running the test, make sure that it behaved in a way that we expected it to. Okay? When we're verifying that our code worked properly, well, how do we do that? Well, the way that we do that is through assertions. There are 3 methods that are available to you: system.assert, assert equals, and assert not equals. And what these do is, here we have an example here. So we have integer x and integer y. We're using assert, which much like an if statement has a condition. If this returns true, so x does equal y, it will just simply go to the next line. But if x does not equal y, this is going to throw an assert exception, and this is how you know that your code is not behaving in the way that it should. There's also system.assert equals, and what this does is it compares 2 values. And so here we have x and y. This would also return true. And then assert not equals, this is the one that would actually fail and throw that assertion exception. Anytime we're making sure that something does not equal it, we can use that one. Okay? Thinking back to that example, so we had that previous example where we had a trigger that's going to insert, so anytime a candidate is being inserted into the database, we're going to do an insert of a contact record. So we're also going to generate a contact record. So taking a look, based on that definition of what that trigger does, what order would you place these in? So if you were writing the test method, or actually not just the test method, but all of the test code, what would you do first? What would you do second? What would you do third? All right, so what do you think would be the first thing that you would do in creating your test code? You're going to create a class, and then what you would do is you'd probably annotate it with the is-test annotation. Okay? What would be the second thing that you would do? Number 5, exactly. So you're going to create a test method, once again, either marked with the test method keyword or the is-test annotation. And then what are we going to do? Number 6, so we're going to create some mock data, okay? And then we're going to insert it into the database, okay? So in this case here we have a trigger that fires on insert, okay? Then we're going to probably query the database. So we're going to find that record in the database. And then our last thing, the one thing that's left over, is we're going to make sure that, maybe we're, I don't know, comparing IDs or just checking to see that it's not null, something along those lines. Okay? One of the things about running your tests is that although we never do the commit, in step number 3 there, you can run a query inside of your test and then find that record. Okay? but at the end, it will never be committed to the database, okay? So it's only within the context of that test. If you have multiple tests, test A will not see the data that was being worked on by test B because they're independent transactions and they both have separate contexts.